Okay, now that you've seen a fairly extensive vocab on this topic and the trig ratios, it's time for some actual practice out of your book. So what I need you to take a look at here with me, again, as a reminder, sine, cosine, and tangent, that's the only ones we're going to actually do. Sine, we talked about this in your vocab, so we can remember the so, ka, toa. And that's pretty much the way everybody remembers this stuff. So, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And that's always the case here. So if you've not watched the vocab video, do that. It's like a half an hour long, so plan ahead for that. So our lovely example. So we take a look at sine of A. Here's angle A. Opposite over hypotenuse, so 15 over 17. Cosine of A is adjacent over hypotenuse. Remember, please remember that the hypotenuse can never be the adjacent, right, or the opposite, technically. Can't be. So, again, so 8 over 17 for that. And then tangent of A is opposite over adjacent, so 15 over 18. So we need to find those exact same thing. And again, please remember you must reduce those. So we're going to find sine, cosine, and tangent for E. So sine of E, and we have cosine of E. Yeah, this should be a capital E, I guess, huh? There we go. And we have tangent of E. And so, again, angle E here. And sine is opposite of hypotenuse. That's 9 over 15. That is not a 5. There we go. 9 over 15, which does reduce to 3/5. And then we have cosine of E. And cosine is adjacent over hypotenuse. And so that's going to be 12 over 15, which does indeed reduce to 4/5. And then finally, tangent of E, and that is going to be opposite over adjacent. So that's going to be 9 over 12, which reduces to 3/4. And those answers are right here in the corner for you. Just as we discussed in the vocab videos, finding a trig ratio, what is the value of cosine 55 degrees to the nearest 10,000? So again, to find that, cosine button, 55, close the parentheses, enter, and we get this. Again, no matter how big the triangle is, a right triangle, and you're looking at a 55-degree angle, it's going to be the exact same ratio, the exact same cosine. It's really important that you put that in your brain. Not the 5, 7, 3, 6, but the fact that all 55-degree angles are going to be the same in a right triangle for cosine. What is the value of each expression in parts A through D? So again, putting them into a calculator, right? So you press sine 80, close parentheses, equals, we get down here, I don't have to do that, and just kind of show you, 0.9848. Now here's ones that are kind of cool when it comes down to tangent. Take a look at that trig tables that I showed you in the other video as well. You can get them straight off there instead of using your calculator. So again, tangent 45, close parentheses, equals 1. Cosine 15, close parentheses, equals 0.9659. And finally, sine 9, close parentheses, equals 0.1564. Now, we talked about this a little bit in the video, noticing the inverse relationship among sine and cosine with respect to the different angles of that triangle. So describe the relationship between a 45-degree sine of 45 and cosine of 45, and explain why this is true. Well, again, we're talking about the ratio of the sides here. If I'm doing sine and cosine of a 45-degree angle, if we think about that triangle, what that really looks like, we already know one of them is 90, right? That means the other two, if one of them is 45, so is this one. So recognize that triangle, right? So sine and cosine, 45 degree angle, is an isosceles right triangle. So the legs have the same length. So the sine and cosine have the same ratio. So no matter what I picked, this leg and this leg are going to be equal, right? So that means that when I look at the sine of this one, so if I look at the sine of here, opposite of hypotenuse, that's the same as the cosine of the other, right? adjacent over hypotenuse, exact same numbers. So that's why that works. Maybe you can see here today why I included the all the examples I did in the vocab, so you had an idea what you were looking at before I started it. Because there's only so many examples here in the book. Find a missing side length to the nearest tenth. What is the value of x in the triangle at the right? So kind of following the thinking here. The measure of so you know the measure of an acute angle, one of them here, right? And you know the length of the hypotenuse. You need the length of the opposite leg, x over here. Use the sine ratio. How do I know that? Again, opposite over hypotenuse, right? Sine, opposite over hypotenuse. So, I know this is a 48-degree angle, sine of 48. Again, I know it's opposite over hypotenuse. I do know the hypotenuse is 14, so I'm really just solving for this x here. The great thing is I can use my calculator like we talked about the other day to find, or like talked about in the last slide rather, find the sine of a 48-degree angle. So the sine of a 48-degree angle, if you put that into your calculator, again, this looks a little bit funky here, but sine of 48 degrees, so put that in the calculator. I'm just going to go ahead and do that real quick here. Boop. There we go. Sine 48. That yields 0.7431. 0.7431. So I know that this right here is 0.7431, and that equals x over 14. So in other words, multiply both sides by 14, and you find x. And at 10.4040, yeah, so about 10.4, that works out just fine. And again, I just included this in here in case you forgot it. For here, what each of those represents, sine, cosine, and tangent. Okay, so this time we want to find the hypotenuse over here. So I know, again, I have no idea what this is, but I do know that cosine is adjacent over hypotenuse. So what we're really looking at here is cosine of 35 degrees. Oh, for Pete's sake. There we go. Got a new pen. I thought it was going to work out better. Cosine of 35 degrees equals, again, adjacent over hypotenuse. So that's going to be 1.575 over the x. A little bit of cross product fun, and this one you can actually put in your calculator. Here's what I did, because I know that I'm going to put this over 1 and do some cross product fun. I put 1.575, so this is what I actually put in my calculator. 1.575, and then I put divided by, and then I put cosine 35, right? Close the parentheses, and then I pressed equals. And so I got 1.9227 blah, 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 right? So about 1.9 is a good answer. We'll take that. Now, we talked about ones like this in your vocab, so we're doing it again. I want to find the angle measurement. And we'll find the measure of each angle. Well, I really only have to find one angle to find the measure of each angle, right? Because this one's already 90, so if I find one of these, I subtract 90 to get the other one. So anyway, what do I have here? Well, if I take a look at angle A, we can start with that one. I do know adjacent and hypotenuse, right? So that's cosine. So if I put this in here again, cosine of A is going to be adjacent over hypotenuse, or 12 over 24, which is 0.5. So then you can use the trig table if you want to. You can look, okay, which angle has a cosine of 0.5? Well, some of these you might just memorize, but that's 60 degrees. But if you didn't, in your calculator, again, we push that second button, right? Push the second button. Then you push cosine button. Then you put in 0.5 and end parentheses. Okay, so again, in fact, let me pop that calculator in here. So again, for inverse cosine, I push the second button right here. Then I push cosine. Then you enter 0.5 and then end parentheses. And then equals. And you would get 60. So second cosine, 0.5, end parentheses, equals, get exactly 60. So if that means if A is 60, that means that C over here has to be 30 degrees, right? So there you go. Okay, so this time it says the side opposite is going to be 8, and the hypotenuse is going to be 12. We don't know this side, but we still want to find what is the measure of angle A. So we know sine. Technically we can use sine this time, right? Sine is opposite over hypotenuse. So what I'm going to write out is I'm going to put sine. You'd think I could finally write on these things. Sine A equals 8 over 12, right? Opposite over hypotenuse. I'm going to reduce that to 2/3 though. I'm going to make my life easy. Now to solve it, again, the calculator here, hang on. So I will push second, SIN, and then 2 divided by 3, and then close the parentheses and equals. So again, that's second, sine, 2 divided by 3, you can use a division sign, and parentheses and equals, and you're going to get a decimal that goes on forever. It's irrational, but it's about 41.8 degrees. Now if I'd have asked you for the other angle, you'd have just been subtracting, but I didn't. I just asked for A, so there you go. So as a brief refresher here, you can use trig ratios to measure some distances indirectly. Now this is real. This is not like made up stuff. This is things people actually do. To measure, to measure such distances, it is often convenient to use an angle of elevation or angle of depression. Angle of elevation is an angle from the horizon up to a line of sight. So if I'm standing here, angle of elevation. Notice from his eyesight, like in the example the other day, the guy was 6 feet tall, or not the other day in the vocab, so you had to add that 6 feet onto the building. So be careful for that. I will try to trick you with it. Angle of depression is an angle from the horizon down to a line of sight. So here, down to the line of sight. So depression, right, and elevation. When you solve real-world problems using trigonometric ratios, you often need to round your answers. The problem may tell you how to round, otherwise round your answers to the precision of the measurements used in the problem. For instance, if the problem has measurements nearest 10 feet, round to the nearest 10 feet, because it's not any better than that anyway. All right, taking a quick look here then. So, suppose you are waiting in line for a ride. You see your friend at the top of the ride. How far are you from the base of the ride? So you see your friend here, your friend's there, you're down here, right? Notice here we have that we're going from line of sight from your eyes then. Apparently this base of the ride is as tall as you are, so that eliminates some of the issue there. So 150, so your eyeballs, right? How far to the end here? Well, we do know the 150 feet here, don't know this part, but I know a 20-degree angle. So, what can I do with that? Well, I know, so what I want to know is here, right, the adjacent side, and I know the opposite side. That sounds like tangent to me, opposite over adjacent. So, tangent of 20 degrees, because I happen to know this angle, I don't know why I know it, but I do, is, because tangent of 20 is opposite over adjacent, what's 150 is the opposite, don't know the adjacent, but I can calculate the tangent of 20-degree angle. And then again, a little cross product fun. And using our calculator, about 412.1216, blah, blah, blah. So here they gave it to you in tens of feet, so you'd round to 410 feet approximately. Computer could get it down exact for us, but again, we're rounding. You're about 410 feet from the base of the ride. And look at those other people in line in front of you. Think of the poor people behind you in line. Okay, so you move forward in the line, and now your angle of elevation is 50 degrees. How you know that, I have no idea, but apparently you're really good at angles, but not measuring distance, right? So, we're going to once again use tangent because we have opposite over adjacent. So the way I'm going to write this out, I'm going to show you what I put in my calculator here. So tan of 50 degrees equals 150 over x. Now again, so what we're looking at here really is cross product fun. So if I put this over 1, right? That means that x times tans of 50 equals 150. Right, so that means x times tan of 50, tangent of 50, there we go. You know what, I need to make that look a little bit nicer. Try to write on these things. Tan of 50 equals 150. So in other words, if I divide both sides by tan of 50, x is 150 divided by the tangent of 50. And you can put that into your calculator. Literally put in 150, division sign, and then tan 50, end parentheses. So let me say it again. 150, division, tangent, 50, end parentheses, and equals. And you get x is, let's see, 125.86. But again, we said we're using tens, so it's about 130 feet. So So approximately 130 feet is what we're looking at there. So, and there you go. You have lots of examples to work. Please ask if you need help. I am happily here. But please make sure you have certainly watched the vocab videos. Don't try to cheat on that and skip over because you need. It's like a half an hour long. So.